Hi, algebra students. Our next page of notes, since we talked about evaluating functions last time, today is just going to be different ways to represent functions. So, of course, we talked about how a function is sort of an input-output procedure, and you're getting input, you're given input values, you're getting output values, but there are different ways that we can represent that. And so we're going to look at different forms. And so the forms or ways in which that functions take. So forms they take. We can represent a function as an equation. We also called this the rule. Right, that was the rule last week. So if it was multiply by 3 and add 7, that would have been the rule. So we can look at functions as equations or rules. We can also look at them as tables, and you filled in a lot of function tables last week, and so we can look at it as a table. We can also look at it as something called a mapping, which we're going to look at today. It's just a different way to represent. We're also going to look at them as ordered pairs, which of course you all have looked at before, ordered pairs. And so ordered pairs eventually lead to a graph. So there are at least 5 ways of representing functions. There's actually more, but these are the 5 that we're going to focus on this year. And so let's just jump right into an example. You're going to be responsible for sort of going between these. So if you look at a graph, can you tell what table it matches with? Or if you look at a set of ordered pairs, can you tell the mapping? If you have an equation, could you tell what the table is? And so we're just going to sort of translate between all of these, and I think you'll see how that goes as we go on. So example number 1, we're going to start with an equation or a rule. So this is what we looked at last week. Of course, we have an f of x. Remember, that just means there's a function, there's a machine f, and we're going to input x values. And so the rule is going to be 4x minus 1. And so this is just one way of representing, that's that first representation, an equation, a rule. There it is. So we could say that that is a function. Now the table that goes with that, actually I'm going to put over here in brackets, this is the equation. I'm just going to abbreviate that, equation or rule is what that is. And then let's go down here and let's look at the table. So here is how we would represent the table given this rule. And so of course you did this last week, and we're just going to do it very quickly. We have a set of x's and y's. Y is also known as f of x, and f of x is equal to 4x minus 1. That's going to be the output. And so we're just going to make up some input values. I always like the inputs to sort of be kind of small and centered around 0. So I'm just going to use -2, -1, 0, 1, and 2. Now, they could be different than that. They don't have to be those numbers, but those numbers are relatively small, easy to do math with, and they're centered around 0. So it's always a good idea to kind of keep them small. And so what we're going to do is we're going to plug in each of these input values, of course, into this rule like we did last week. So this first one is going to be 4 times -2. Drop a -2 in for the x minus 1. Then we're going to have 4 times -1 minus 1, 4 times 0 minus 1, 4 times 1 minus 1, and 4 times 2 minus 1. And so we're going to get those output values for each of those. And if you do the math, this is actually 4 times -2 is -8. Take away 1 is -9. 4 times -1 is -4. Take away 1 is -5. 4 times 0 is 0. Take away 1, that's -1. And 4 times 1 is 4. Take away 1 is 3. 4 times 2 is 8. Take away 1 is 7. And so that's what my, getting rid of all of this math work, our table should look like a table of values of -2, -9, -1, -5, 0, -1, 1, 3, and 2, 7 in the table. And so that would be how we represent this function as a table. Now, let's talk about a mapping. So let's move over here to mapping. And so this is what a mapping is going to look like. Maybe I should be underlining these to make them sort of distinct. So this is what the mapping should look like. Now, a mapping is actually 2 circles. So they represent inputs and outputs as well. So this first circle is going to represent the inputs. Second is going to represent the outputs. So it's very similar to a table, only the representation is different because notice here I'm going to put my inputs all in this circle. Now I am going to keep it least to greatest. So remember my inputs were -2, -1, 0, 1, and 2. It's important that that goes from least to greatest in your input circle. And then for the output circle, we're going to also keep it least to greatest. Now this is already in least to greatest, so we don't have to worry about it too much here, but the outputs were -9, -5, -1, 3, and 7. So we just list them in order, least to greatest. And then it's called a mapping because what I'm going to do is I'm going to match them up with arrows for the ones that correspond. So notice that -2 corresponded with -9. So I'm just going to draw an arrow over there. -1 corresponded with -5. Draw that arrow. 0 corresponded with -1, 1 with 3, and 2 with 7. Now this is a really nice example to start with because notice the arrows just sort of go straight across. That is not always the case. We can get all kinds of crazy arrows in here. So we'll do another example here in a minute where that's the case. But this is, again, what's called a mapping. Inputs in one first circle, outputs in the other. We're actually going to talk about in the next video, we actually also, within a mapping, we call the input values a domain. And we call the outputs a range, but again, we're not going to worry too much about that right now. We will get to domain and range in the next video. All right, so now that we have 3 of our representations. We have the rule, we have the table, and then from the table we were able to take the mapping. Notice you could, of course, match the equation to the mapping, right? Because really all we did, again, was we took the input, plugged it in, and got the output. We just drew an arrow to it. So you could also start with the rule and not even have to do the table. You could just go straight to the mapping. All right, but now that we have this table and mapping, we can actually take either of these, it does not matter which, to our next representation, which is ordered pairs. So now we're going to look at ordered pairs. And so if you will remember from your past, ordered pairs, of course, just are sets of x and y values in parentheses that we use to put on a graph, right, on a coordinate plane. And so we're going to do that here in just a second, but we're going to list out our ordered pairs. Now when we make this list, sometimes, most of the time, we will see them in these little curly brackets, and then we'll see the set. So I'm going to draw a little curly bracket to indicate these are all going to be ordered pairs. And I'm going to start with my first ordered pair, which is x value of -2 and y value of -9. Notice you could get that from either place here. So I'm going to match up -2 is my x and -9 is my y. That's just the output value that goes with the input of -2. And then I'm going to put a semicolon in between them. So notice comma in between the actual coordinate plane, but I'm going to put a semicolon between these. And then we're going to do the next one. So the next pair would be -1 is matched up with -5. Again, I could get that over here from the mapping as well. Semicolon. 0 matches with -1. Semicolon. 1 matches with 3. Oops, put the negative there. Here we go. No negative, just 3. And then semicolon, the last match is 2 and 7. And of course I'm going to end that with a curly bracket as well, saying that this is the set of, curly brackets mean set, of all of these ordered pairs. And of course, again, I got those from the table, x and y, or I got them from the mapping, x and y. So those are my set of ordered pairs. And then the last representation, and again, notice, let's go back up here to the rule. You could have, of course, went from the rule and just pick some input value. So you could start with 4x minus 1. And of course, you could have said, okay, my x is going to be -2. What's my y going to be? Plug in -2, get the answer, and then just write it down for the y. So you could also go directly from the rule to a set of ordered pairs as long as you have some input values. And then last but not least, of course, we're going to have the graph. Now, the graph is really nice once we have the ordered pairs, but you could also just sort of pair them up from a table, right? So if you have x and y values, of course, you can just begin graphing them. But we have them written out nice and neat here as ordered pairs. So I'm just going to sketch a graph. So, of course, a graph has a y-axis. I'm going to use the rest of my page for this. And an x-axis. So I'm going to draw that somewhere in the center. Make it nice and neat as you can. Oh, let's go up a little bit. So label that. That's the x. That's the y. And then I'm going to put some tick marks to keep everything straight. So I'm going to use every half line of my paper. So I'm going to put like a little tick mark right on that line above there. Notice I started here in the half. And then I'm going to put one at half. And then I'm just going to go up every half step. So like line, middle, line, middle. And then I'm going to do the same thing this way. So line, middle, line, middle, line, middle, line, middle, line. And then I guess I could do one more down there. And then about the same amount of space, I'm going to go side to side. So it doesn't have to be perfect, but try to keep it nice and neat. So I'm just going to draw off some tick marks that direction, draw off some tick marks that direction, evenly spaced, about how I drew my Y's in. All right, and so now I'm just going to fill in my ordered pairs. So notice my first ordered pair here is -2, -9. So remember how to graph that? First go side to side, so -2, and then -9, of course, goes down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and make sure it's kind of lined up with that -2 tick mark. So over -2, down -9. So there's my first order pair going to be plotted right there. -1, so over -1, down -5. 1, 2, 3, 4, 5, down. 0, -1, just going to be right here. 1, 3, it's going to be over 1, and then 1, 2, 3, up 3 tick marks. And then over 2, and then up 7. 1, 2, 3, 4, 5, 6, 7 is going to be on that line. Now, what do you notice about all of those dots? And again, the neater your graph is, the better this is going to look. But hopefully you should notice that they are approximately linear, meaning that they fall in a straight line. And so what I'm going to do is I've just got this like loose sheet of paper over here. You could use a ruler. You could use anything you got. And again, they won't be perfect because we're hand drawing this, but I'm going to approximately line up something straight that will go through all of those lines. And I'm just going to draw a line through all of those points, connecting them. This would actually go on, right? The more and more inputs I have and the more and more outputs I get, this line would keep going because I could keep graphing points up this way as well as in the other way. And so I'm going to draw an arrow at the end of my line to indicate that it keeps going. And so those are the 5 ways of representing a function. We've got our rule. We used our rule to generate our table, mapping, and ordered pairs. And then we use the ordered pairs or the pairs found in either the table and the mapping to actually create coordinate points for our graph. Now, the logical question is, will they always end up in a line? So is a function always a line? So let's look at another example. You can either go on the back, the next page, or get you a new sheet of paper. So I'm just going to go to the very next page here. And let's look at a different example. So example number 2, and see what happens. So I'm going to give you the rule. So the rule is f of x is equal to x squared plus 1. So here's our new function rule or equation. First thing we're going to do is we're going to create a table, our table representation. So I'm just going to draw an x and a y. And again, you could use whatever you want for input values, but we're going to keep them small. So I, again, am just going to use those pretty basic numbers of -2, get some negative numbers, get some positive numbers, get 0. It just sort of, everything's around the origin when we use these as input values. So they're just good standard numbers to use. And of course, we're going to plug those in, right, into our rule. So just like we did last week, evaluate the function. And so the rule here would be to plug in -2 as my input. I'm going to square it, and then I'm going to add 1. So same thing here, -1 squared plus 1. Just replacing the x with the input value, 0 squared plus 1, 1 squared plus 1, and 2 squared plus 1. Now remember, it's really important, especially with negative numbers, to put them in parentheses, especially if you're going to use Desmos to square them. And so let's see if we can find the answers here. So you could type these in or evaluate them yourself. Remember, a negative number squared is positive. And so the answers here actually come out to be 5. That's 4 plus 1. 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. 1 squared is 1. Plus 1 is, again, 2. And 2 squared, again, is 4. Plus 1 is 5. And so we get our output values for our table. Now we're going to draw our mapping. So remember, the mapping is 2 circles, sort of egg shapes. And remember, we want them least to greatest. So these are input, these are output. In other words, we could also call them x and y, or we could call them domain and range. Again, that's not too important until the next video down here. But let's make sure they're in least to greatest. So these are already in order. -2, -1, 0, 1, and 2. But now check out my outputs. Because I actually have some outputs that repeat here, right? And so we want the least of the outputs. The least of the outputs is actually 1 here in the center. The next least is 2. Now it repeats, so I do not have to write 2 and then 2 again. I can just write 2. 2 was an output. It was an output twice, but it's just that number. So you don't have to write it twice. Same thing with 5. 5 happened twice, but I'm just going to write it once because 5 is an output, even though it occurs twice. And now I'm going to fill in my arrows. So -2 map to 5. Now here's where I tell you that sometimes these arrows are going to cross. So -2 maps over to 5. -1 maps to 2. 0 maps to 1. 1 maps back to 2. So we're actually going to have 2 arrows going to 2 here. And then 2 maps directly across to 5. So it looks a little bit more spider web-like over here. But again, the mapping must be from least to greatest, and so it's okay if our arrows match. Again, it's also okay if you've got 2 arrows going to the same spot. It is still a function. All right, so there's our table, there's our mapping. We're going to write out our ordered pairs real quick. So remember curly bracket, and we're just going to match these up. So -2 matches with 5. It's a little easier to get them from the table because they're right across from each other. -1 matches with 2. 0 with 1. 1 with 2. And 2 with 5. I'll give you a second to catch up writing that. So those are all of my ordered pairs that are matched up. And then I'm going to create a little tiny graph here. I'm not going to make it as big as the last one. We'll just make it pretty small. And so I'm going to draw a little small graph here. I'm going to put myself some tick marks on here. So every half step. This is maybe not as straight as my last graph was. So put you some tick marks on there, and then we're going to graph these. So the first point is going to be -2, 1, 2, and then up 5. 1, 2, 3, 4, 5. It's actually going to end up here. -1, and then up 2. And that ends up here. 0, 1. 1, up 2. And over 2, up 5. 1, 2, 3, 4, 5. Now, does that look like a straight line to you? Not quite. And so just be aware that functions will not always be straight lines. Actually, this creates a shape that's kind of like a U. And it actually has a fancy math name, but it looks like a U. We're still going to put arrows on the end of it because it does continue to go. If we put in like -3 or -4 as an input, or if we put in 3 or 4 as an input, we get out larger values. But this shape right here, this U shape, actually has a name, and it's called a parabola. P-A-R-A-B-O-L-A. Parabola is the mathematical name for that U shape. And it could be facing any way. We could actually have parabolas that are turned upside down, or we could have parabolas that turn sideways. But they're these U shapes that come out when we're dealing with functions. And so parabolas are going to show up, and so this one is a parabola. It actually has to do with the fact that, notice our first example here did not have a square, but we actually squared here, which is what caused some of these outputs to repeat. And so it causes the U to kind of come down and then to swing back upwards. All right. So I'm going to give you one more. And so I've got a little bit of space down here at the bottom. I'm going to give you one more rule. So example number 3, I'm going to ask you to do this one on your own. So example number 3 is going to be f of x is equal to -3x minus 2. I would suggest maybe pausing the video and see if you can create the table, the mapping, the order pair, and see if you can graph this, and then we'll go through it very quickly here in just a second after you've paused the video and tried this one yourself. All right, so I hope that you stopped and paused the video. We're just going to go through these answers very quickly. So for x and y, again, if you use the ordered or the input values we have been using, which I'm going to use, you should have got, and I'm not going to go through all the math, but you should have got the output value of 4, 1, -2, -5, and -8 as your table. That's what your table of values should look like. Your mapping, of course, your inputs mapped to your outputs in order least to greatest. Again, we have -2, -1, 0, 1, and 2. Now be careful with the mapping here because you want to go least to greatest. So you should not have put 4, 1, -2, -5, -8. Actually, -8 is the least, and so it has to start at the bottom. So these actually go backwards. And so it's important to be least to greatest. And so that means just your arrows are going to cross. So -2 goes with 4. -1 goes with 1, 0 goes straight across to 2, and then these go backwards. So 1 goes to -5, 2 goes to -8, and so they sort of cross there in the middle. Your ordered pairs are going to be -2, 4. They're going to be, I'm going to put those in curly bracket, they're going to be -1, 1. They're going to be 0, -2. they're going to be 1, -5, and they're going to be 2, -8. So those are your ordered pairs that you should then graph. And I'm going to have to graph real small down here in the corner in order to get this to fit on here. And actually we've got -8. I'm not even sure I'll be able to graph that. So let's see. Real small, 3, 4, 5, 1, 2, 3. Probably only get down to 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we start out with -2, +4. 1, 2, that's here. -1, 1 is right here. 0, -2. 1, -5. And if you can imagine where 2, -8, it would actually go off the paper down here at the bottom, somewhere out here. But these do end up being, there's no square in my rule, so they do end up being a straight line, and so we could connect them, were my graph to be perfect. They would connect very well, connect them with a straight line and draw arrows on the end. All right, and so those are all the ways of representing functions. Of course, in your practice, you're going to maybe go from a set of ordered pairs back to a mapping, and so you want to make sure that those are matched up correctly as how they're matched up here, or you're maybe going to need to plug in some inputs to actually get the outputs to make sure this rule matches this this mapping. You're going to need to, maybe even if you start with a graph, if you're given a graph and you're asked to match it to some ordered pairs, you're probably going to need to go through and actually pull out the points and say, hey, like there is the point, -2, 4, and you may have to label them or write them down. This is -1, 1, to actually get some points off of the graph to actually match it to some of these things. And so you're going to be matching up different ways of representing functions. And so best of luck on your practice.